It started with a 30-year-old consensus algorithm. Mathematically speaking, it was perfect. Practically speaking, it was unusable. We weren't the first to discover it or rediscover it. We were simply the first to ask, what if we could fix it? What if we could re-engineer it to power a global decentralized network? So we did. The private permission ledgers came first. The community came next. That was the moment things got really exciting. We started testing relentlessly. And when the numbers started coming in, we knew we had it. An impossibly secure, lightning-fast, perfectly fair public ledger. Hedera is really the beginning of a new era. For the first time, we're going to be able to build the internet we want, all powered by native nano payments. An internet where objective news reigns again because publishers no longer rely on advertising dollars. An internet where the economics of spam no longer make sense, but the costs to send an email are still negligible. An internet where musicians are fairly compensated for their work because they can sell it directly to fans by the stream. Of course, this isn't just about transforming the internet as it is today. It's about maximizing the potential of the internet as it will be tomorrow, where all major elections happen online, free from manipulation and voter suppression, where sprawling virtual worlds can be spun up in an instant, no server necessary, where privacy is guaranteed, and where your identity is always controlled by you. This isn't Hedera's vision of the future, it's yours. Where we go from here is up to the engineers and the innovators who build on this foundation. Ready to get to work?
Okay, so this table over here means that we're going to have a little bit of a fireside chat. It's not a panel conversation, it's not a keynote. It's just two guys who love technology, talking about technology. Pay good attention, because right after this we have a coffee break, and it might be nice for you to have a chat with people around you or these two guys about technology. I'm going to introduce them separately. So the man with the bow tie first, that's his cue, so he knows who's going to come up first. He has been a huge support to Blockchain Summit, was one of the judges last year in the competition. He's the Vice President of Technology Strategy at Luxoft. He also co-founded the nonprofit Crypto Valley Association. I've got a fact about his kids. He has read the complete Lord of the Rings saga to them, not once, not twice, but 3 times to them. Now they love literature. Please put your hands together for Vasiliy.
Hey, Dan.
All right, have a seat over here, sir.
All right.
Excellent. Next up, he and his business partner actually started off in the US Air Force as officers. They've got 3 startups together, they've been working for 20 years. Mance appreciates and respects his business partner so much so that his son is named after his business partner, Lehman. Please put your hands together for Mance. All right, gentlemen, you've got 20 minutes. Take it away. Future of blockchain.
Right. So yeah. So let's get started. I think first the whole consensus algorithm, which is so a movie about, came around what in 2016. People started to learn about it, and initially it came in the form of Suvorov, which was a company focusing on enterprise use cases. Right. Since then, people started to wonder about it, and I think now we really have 2 camps. The real believers that think that this is the blockchain killer. People for some reason like to talk about killers. And then others that kind of ignore it, right? So for whatever reason. So now I think you made a bold step to really take something that was designed for enterprise use case, for a private blockchain type of things, or DLT, and now move it into public space with Hedera.
Right.
So what actually made you make that move?
Well, so it was always the intent to have a public blockchain, a public platform built on Hashgraph. The technology has been in development since 2012 by Dr. Lehman Baird, the inventor of Hashgraph. And he had this breakthrough in 2015, which is now what we call the Hashgraph. But we took a look at what the problems were in the market that sort of prevented mainstream adoption of the public networks. And we came up with some solutions to those, but it required that we start by building an enterprise-grade product first. And so that was Swirlds, and Swirlds to be clear, continues to exist as a company that's focused on permissioned networks, enterprise use cases.
Happy? Yes.
And then Hedera Hashgraph, who has just been spun out last fall and introduced to the world in New York last month, is chartered with creating a public network. And Hashgraph, there is no company called Hashgraph, just to clear up a little bit of confusion here right now. Hashgraph is just the algorithm, but the governance model that we envisioned for Hedera was intended to be designed to be the most distributed and decentralized governance model of any of the public platforms. And the way in which we bootstrap this proof-of-stake system requires a governance council that is trusted by mainstream markets. And what that means then is that the members of this network, this council, are the largest members, largest enterprises in the world by both market cap and by brand trust. And we knew we couldn't create that council until we had market validation of the technology. And that started with the enterprise, that we had to start by not just writing a white paper and raising money and going and trying to build a product, but first build the product, address real enterprise use cases, get market validation. That then enabled us to create this council, which is critical to the function of the public network.
Okay, so let us talk about the proving the technology with the real applications. Because when we look at Hashgraph, right, the Hashgraph and I think original SDK is really it's not an off-the-shelf system, right? It's really a way to build, DLTs using the consensus algorithm.
Absolutely.
And now we go into a bit of a deep technical territory here. So consensus algorithms are all about synchronizing state, between multiple, distributed systems that participate in this decentralized, distributed consensus, right, about, state of, whatever transactions you have, right? Yeah. And I think with your SDK came a number of different sample applications, how people could use it. And I think one of your initial customers was CU Ledger, right?
Correct.
The financial, union of, the private, I guess.
Credit unions in North America.
Yes, in North America, right. So, so what was the result of that? So how many people actually were running the nodes? What was the throughput?
Sure. Well, with CU Ledger, the credit union industry in North America, 6,000 credit unions, sort of collectively decided to create a new, what we call credit union service organization. It's an organization that's created for the industry to provide services to the industry. And CU Ledger wanted to build which is a CUSO, Credit Union Service Organization, wanted to build an arbitrary a platform that enables arbitrary applications to run on top of it. So the credit union industry has third-party developers today that build apps for the industry. CU Ledger will have an app store that makes it possible for those same developers, that community, to build distributed applications and market those through the app store to the credit unions in North America. We worked with them and won that business in February of last year, and work with them through the remaining part of the year to continue developing the product. And they just began rolling that out in Q1 of this year. My understanding is there's something on the order of 20 nodes, 20 credit unions. Their expectation is to scale that up in the coming couple to 3 years to the 6,000. And the initial use cases are related to identity and to messaging and to threat information exchange, so the credit unions can more appropriately calculate risks, and to making it possible for the credit unions to address loan opportunities collectively that they might not be able to address individually. Those sorts of applications are the initial set that are being built on top of the platform.
So would it be correct to say that in terms of proving, you kind of proved, yes, people can build applications on it, but in terms of making the leap to a grander scale, because I think if you look at the Hedera white paper, you talk about millions of nodes, people potentially running it. Of course, you talk about sharding, kind of partitioning this large network, but still, I think even in the test run that you talked about, what, 5 continents, I think, is that correct?
Yes, on AWS.
AWS, right. So, but I guess it's just a handful of nodes. Still, I think 39 nodes. Is that?
Yeah, actually it was 32. It was 32 nodes.
32 nodes, yeah.
Yeah, so, no, absolutely correct. The sharding that's described in the white paper is not yet implemented.
Right.
and that will be implemented later this year after we've rolled out the first version of this product. It's always the question, well, how can this scale? How large can you make this? And this gets a little bit technical as well, but in a sharded solution like the one that we're creating, you really only want 100 to 200 nodes. And then you want as many shards as possible. So new nodes join the network. You want each individual shard to be secure. And what that means is, as long as not more than a third of the nodes are colluding to do bad things, then the shard is secure. And so you have to ask yourself, if there's a shard and nodes coming online are just randomly placed in shards, then how many nodes do you need within a shard to have a high level of certainty that it's secure? And then you don't want to add any more, right? You want to take new nodes and create new shards. The more shards you have, the faster some applications can run.
Right, and I think it segues nicely into this aspect of Byzantine fault-tolerant algorithms, because yours is in a sample of that, and of course yours is a synchronous Byzantine fault-tolerant algorithm, and we know from FLP theorem from 1985 that these things do not exist, right? So basically, what gives?
Well, they do exist if you have randomness in the system, and the way in which we add that the randomness is in the gossip protocol. So when we, again, pretty low level technically here, but when we're communicating with different nodes within the shard, we're randomly choosing nodes with whom to communicate. And the addition of this stochasticity makes it possible to actually achieve asynchronous BFT, provably.
Right.
And so, I mean, we're way down in the weeds here. But it is, in fact, possible. It's in the white paper, and there are formal proofs. Right. And this has been presented to, Berkeley and Harvard and others.
Right. But and I think, where it actually gets interesting for me is, as a practitioner, somebody who actually works on implementing systems for enterprise, it's always important to understand the fundamentals of technology. Sure. And, for example, if you're a services company, right, you don't want to do research, right? You rely on peer review for academia, for example. Yeah. If you look at Hashgraph white paper, not the Hedera white paper, the original
technical paper.
Right. It's well written. It's fantastic, and I think Dr. Baird is a great lecturer, very passionate about technology. But there's not enough reviews, right? So, for example, there's a Zurich lab from IBM that does a lot of research in consensus algorithms, and they published a paper last year called "Consensus Algorithms in the Wild," and yours gets one sentence. Basically, right?
Fair enough.
So why is that? Why is that? Do you think people are not reviewing
It's a fair question. Right. So there were a couple of reasons that we've held off submitting to. In fact, we will submit to VLDB for peer review. There were two things that prevented us from submitting prior to this point. One, we wanted those formal performance results that we now have as of a month ago that we published in AWS. In addition to that, we've added a formal proof of fairness, which doesn't have anything to do with asynchronous BFT. It goes beyond ABFT. Now that those are complete, this is being submitted to VLDB for fuller peer review.
Right.
Yeah.
Okay. So that's great. But one of the things, if I made a suggestion, because I do read a lot of white papers on consensus algorithms, and in academia there's certain language people use to study those, right? And they talk about safety and liveness. Unfortunately, those things are not even mentioned in your white paper. But when you say, okay, so we do randomness and we're able to converge, agree on the consensus of ordering things, what you actually mean is, well, we know we will converge with probability 1, means it will definitely happen, but we don't know how long it will take, right?
Absolutely.
So, and that's the liveness aspect, right?
Understood.
And the safety, of course, as well. Yeah. As long as there's less than 1/3, adversaries, we can be safe, right? People cannot cheat the system, right?
That's correct. So I mean, absolutely. I mean, with probability 1 is the key component here. In practice, what we can say is that what we've seen is that it only takes half a dozen what we call gossip periods in order to come to convergence. And the circumstances under which it would take longer to achieve that are very rarely occurring. But to your point, it's a new algorithm. It's something that we are now testing in larger and larger deployments. But what we can say is that it looks like, empirically, it's working quite well. And, and from a theoretical perspective, it achieves something that's been very difficult to achieve for decades. So we're very excited about the prospects of deploying this on a broad scale.
Well, excellent. I see Dan is approaching us. I guess
I have creeped up on your fireside chat over here. But thank you guys so much for sharing about Hashgraph and the future of blockchain. Could we please put it together for Vasiliy and Mance? Thank you, guys.